Okay, welcome back everybody. I've put a cloth cord on it. Starting out with a 1/2 amp fuse in the radio. That'll be real close, but I normally put about a 1 amp in there, but today I'm using a 1/2 amp just so that it'll blow long before hanging. I've got our meter hooked up to our B plus, and looking at it, somewhere around 225 volts maybe. We'll look and see. So let's got speaker hooked up, got everything lined up, got the variac down. Okay, power's on, antenna hooked up, so we're going up to about 30 volts. See a little current, not much. Look like a little DC coming up, excuse me. Let's go on up about 60 volts or so. All right, getting some B plus there. Starting the lamp to light a little bit. We're up to about 206 volts. All right, the current is still low, less than 200 milliamps. Going up to about 90 volts or so. B plus is coming down. Don't hear anything. It's going up to about 110. We're looking at about 360 milliamps. B plus is around 214, 13.
And get genocide drawline.
What about that? Got sound. There's a ball game. All right, just shy of 400 milliamps. This is awful hard. This is a tone switch. I didn't grease that. Maybe I should have, huh? Treble, bass. B plus is looking about 215, and that's a little bit lower than the 225, but good volume. All right. It's going up to about 115 volts. Now we're setting on 225 volts where it's supposed to be.
Wedding. Third wedding. She was only 29. During the Civil War game, my whole family lives in Oregon. Huge fan. Had to suck it up and go. And it was Herbert's first.
All right, looks like we have success.
I don't know. Do you have to go to someone?
At least it works. We'll go in, we'll check the voltages, and start putting it all back together. Then we'll work on the cabinet a little bit. Okay, I apologize for the audio on this. I had to dub over it so you really can't hear the sounds, but I discovered I had a problem. The upper part of the band worked really well, But then when I went to the lower part of the band and got down to about right there, the radio receiver went dead and popped and went dead when I bring it back. So I discovered that this little, let's see, right here, the plate, as you can see, it's bent right there. I get a good light and you can see it's touching there. So I had to go down in there and to straighten that out. I think I can get some pliers and do that. Okay, we'll try to show you something here. Trying to hold the light and the camera at the same time. I'm sorry for the angle, but this I moved that around a little bit there. I thought that it was still hanging there, but I got to looking. I'm still receiving till I get to right there, and I thought that was the problem. Watch what I do here. I come back to where I'm receiving. You can hear it's receiving. And I'll take a piece of veneer and stick it down in here between those two plates. See which, there's that light. That was causing all the noise. But you see I'm receiving with that in there. So the problem is down in this part of the plate, not up in here. Well, I've done straighten this part up here, but we'll see if I can figure out why that is rubbing down in there. Okay, that's fully meshed now. You can tell. One of the stationary plates were bent out just a little bit and pushing towards that side. So there we go. I think that's...
Well, good for you.
Well, thank you very much.
It's much more than that with those guys.
All right, I'm going to do some voltage checks and then we'll swing to the cabinet. Alrighty. Last night when I was testing, when I first powered it up, it was late at night and was getting a lot of skip and what have you. I thought I would give you a demonstration during the day at how the radio performs. So we'll start at the low end of the band and work our way up, and we'll just see what we can find. Low end.
Bang, bang, bang on the door, baby.
It's WLOD. I love that station. It's only a daytime station up the road. Plays all old country classics.
Right now it's 6.
Grand Princess Cruise Ship Outbreak.
Back in rewards when you buy $75.
New case.
Little pink forward. I get a little skip. It's about 4 p.m. Alright. There's another station I wanted to find. Okay, it should be right along in here. That's it. It's Jet Fly WFLI down in Chattanooga, 1070. Alright, just wanted to give you a demonstration during the daytime. I went through the radio and I did all the voltage checks. If you'll look here, this is the chart that was given in riders as far as the what the voltages should be. And if you'll notice the note down at the bottom, it says that the readings are taken with a meter that has 1,000 ohms per volt. We'll get into that a little bit later on, but I did the voltage checks and all of them came out close, except for 2 of them. One of them was the output tube. If you'll remember, it called for a 6F6, and someone had put a 6K6 in it, which was a substitute. So I went ahead and put the 6F6 in there. It doesn't look like much, but I put it in there, and there was virtually no difference in it. And then the other tube that had a discrepancy in the voltage was the 6Q7, which was the second detector ABC tube. If you'll recall, early on in life, early in the videos, that 6Q7 tube triode part of it was weak. I told you it was weak, but I was going to try it anyway. So I did, and the voltage, if you look at, let's look at the 6F6 voltage first, and they all, the top line is the spec voltage, what they call for, and the bottom line is what I measured. And if you'll look, they're all in line except for the one on pin 5. Okay, so let's go to the tube 6Q7 voltages. The spec voltages are on the top line, and then the measured voltage was is on the second line. Now you'll see on pin 3 that my measured voltage was higher. Now the first tube, the weak tube that I had, was reading 121 volts. So I put a better tube. Of course, it wasn't new, but it tested really good on my tester, and I put it in there, and now it's 109 volts versus 54. So let's address what's happening with these two tubes. we'll take the 6Q7 first. The plate voltage on the triode is not loaded that much. So the meter that I'm using, which is my Fluke 15B, is high impedance, 11 megohms or something like that. So it's not presenting any load on that circuit at all. And in the old days, with the 1000 ohm per volt meter, it was, depending upon the scale. Now the scale had a lot to do with it. The scale or the impedance or the resistance of the meter would actually drag that voltage down, increase the current in that tube per se, and drop that voltage. And that's the readings that they were given. Now on this 6Q7, I'm showing 109 with my modern meter. So if we had a 1000 ohm per volt meter, we could probably get closer to that. Now, just the weak tube, the weak emissions or the low emissions in that tube will cause that voltage to be high to start with. And you can see that with the weak tube, it was 121 versus the 109 with a better tube. So what do we mean by a 1000 ohm per volt? Well, let me clarify that. Let's say we've got a meter that's 1 milliamp. It's a 1 milliamp meter. And it draws 1 milliamp or 0.001 amps at full scale. This resistor in line is the multiplier. So in order to determine this resistor, we've got to use the resistance is equal to the voltage, and if we want this meter to read 1 volt, we got 1 volt is the voltage over the current. 1 volt divided by 0.001 amps is going to equal 1000 ohms per volt. Okay, let's say that we want this meter to, at full scale, to read 250 volts. To determine the resistor of this, we use the voltage, the 250 volts, divide that by the current drawn by the meter at full scale, 0.001, and we end up with 250,000 ohm resistor as the multiplier resistor. So, and if we want this to be 500, we do the math, it's 500,000. If we want 300 volts, it's 300K. If we want 150 volts, it's 150K. Now, the internal of this meter does have some resistance, but it's a lot smaller than this. So for the sake of the demonstration, we're just saying that's negligible, and we're just using the round numbers, the larger numbers here. Okay, I looked up the specs on my Fluke 15B, and it's 10 meg. So let's check the pin 3 on the 6Q7, and the last reading I got was 109. Right now I've got 111. Okay, and it's supposed to be 54. Okay, pin 5, I believe, if I'm pin 5 on the output tube should be what did I say it was? Should be -4, and we're reading -23. So what we're doing is we're putting, and this is measured from ground to these points. Well, back in the day, Zenith and their engineers, or in what have you. They were using those meters that were putting 1,000 ohms per volt. And what I'm saying, right now we're doing 10 meg, so it's not loading the circuit at all. So that's really probably what the circuit is really, the voltages are there. It's putting very little effect on the circuit. But what they had to measure it with was, the engineers documented the readings that the field technicians would actually see. I went on Antique Radio Forum, or ARF, and read some of the articles and what have you, and there's quite a few articles. There's talking about the 6Q7 being weak would cause the voltage to go up. That's where I learned that. Also has talked about the loading of the and the thing about it is we don't know which meters that they were using. So the biggest talk on ARF was a 250 volt scale. So in order to do that, we have to shunt our 10 meg ohm meter and with approximately 250,000 ohms. So I took two 10s. All I had was a 270. So I took some 510Ks and I paralleled them and made a 255. So that's fairly close. And so we're going to take some readings and we'll see how, if it should come down. It should load it down even more than just the 10 meg. You saw, you didn't even hear it pop. Now, I'm warning everybody, if you got earbuds or earphones, you're probably going to get a pop. I've got the volume down, but you're still probably going to get a pop. So let's check the voltage here. And we are getting, now we're down to 73 volts. That's closer. That's closer. And then we go to up here to pin 5, and we had what, 23 the last time, should be down to minus 4. Does that sound right? Yeah, something like that. Let's see how close we get now. If I can find that up in there. There's minus 5.7 or minus 6 or so. So we just showed that we did load the circuit down somewhat, and we don't, like I say, we do not know what meter they used, and Zenith may have had their own test equipment they built. I mean, they built radios. Why couldn't they build their own test equipment? But they used what they had, and the field technicians, they put those numbers out there for that 1,000 ohm per volt because that was the standard meter of the day. So around World War II, then it started getting to be 20,000 ohms, and a lot, I think my analog that I've got, my Simpson and my Radio Shack one over here is 20,000 ohms per volt. But I got one more. Let's do one more experiment. Okay. Let's say they had a 150 volt scale. Okay. So I put a 150,000 ohm resistor and shunted it across there. Let's do our measurements. Remember, we should have 54 down here, and we should have minus 4 up there. Okay? Watch your ears, guys. There's 53. A little over 53. That's close. Let's go up here and check this one. Oh, yeah, I can't get a good connection up here. Minus 3.7. So, did I just make the data fit what I wanted to? No. What I've done is I proved that we're loading the circuit down with different meters and different resistances, and that's the point is not to really be all that accurate, just to show that in the day they were using different equipment than we're using now. And if you're getting some weird readings, write them down and think about it. and look and read the notes, because this said that they were using a meter that had a lower resistance than what we're using. So that's what I do. And I really appreciate Rick from All American 5 Radios. I reached out to him, talked to him about it. Don with Restore Old Radios talked to him about this, and got some advice on it and what have you. And so I went with the 250,000 ohm resistor across my meter to load the circuit. It did bring it down, but then I went to the 150, thinking that, hey, maybe they had a 150 volt scale. And so those numbers were more in line. So the radio's playing great. So I feel good about that, but I just wanted to show you that, how to load that circuit down. And you guys already know that certain pins you touch on with your meter detunes the circuit and causes the radio to quit. So you know the effects of the measurements, and all their reference voltages was make sure you were in the ballpark. I pull the speaker out. It's held in by 4 screws with some lock nuts. The nuts go up in the wood, and then these are stationary. And it's got a beveled head, kind of a shouldered 3-tier there. The grill cloth is very similar to the one I just pulled out of the Philco. Kind of a copper color. I don't know if it really shows it or not. I don't know if that's a herringbone or what, but I like that. Going to take this down and strip it. Looked like somebody took a hammer and beat on it in the corner here. So I'm going to strip it all down. Let me show you some veneer. It's going to have to be worked on. Okay, here's some veneer that's kind of missing here. And on this end, it's pulled up a little bit. I just wonder if it would be just as easy as it's pulled up here. I just wonder if it'd be just as easy to check the grain out and see how it runs, and see if I can replace that whole strip there. But the rest of it is in pretty decent shape. Okay, this one is running on long enough. So we'll just end it here. In the next one, we'll assess this speaker, and as you can see, we're going to have to do some patching. So, got a lot to do, short time to do it in. Appreciate everybody watching. So, from Larry, from the hills of Tennessee, thanks for watching.